Hello, Geometry. This is Mr. Szabo, and what we are going to talk about today is sections 2.1 and 2.2. So it's going to be dealing with perpendicularity and then complementary and supplementary angles. So the key is we are going to talk first about perpendicularity and just a couple of examples in the video. Then we'll go into the complementary and supplementary angles and just a couple of examples in the video. When we get to class, we're going to get a lot of practice on all of this material, and so it's going to be more of a flipped classroom model as we get into this week in particular. And then we will kind of debrief and see how things are going with everybody. So, without further ado, section 2.1, perpendicularity. When we are talking about two or items being perpendicular, we are talking about lines, or we are talking about rays, or we are talking about segments that intersect and form right angles. And we talked already this semester about right angles being 90 degrees. So we're actually adding a layer into our step and into our thought process when we're talking about if-then statements. So if lines, rays, or segments are perpendicular, then they form right angles. If they form right angles, then they're 90 degrees. That's a chain that will have to be followed. It is not a direct relationship that we're ever really going to be able to take. This is a definition, so it is reversible. Okay, so we can state that perpendicular, that's the sign for perpendicular, then if and only if, so we can use this arrow, so perpendicular implies right angles is true. That's what this definition states, but because it's a definition, it's reversible. Right angles also imply perpendicular. And the other couple keys here, this little box is showing perpendicular. That's how we would mark angles as perpendicular. If it's one angle, you just need that one box there to show that it's perpendicular. But if it's four angles like this, you still only need the one box. Okay? You don't need to put that right angled mark in all four angles. One is sufficient. And we would state that line L, lines that are named with cursive letters, if it's not 2 points, is perpendicular to line M, or we could state that in this case segment AB is perpendicular to segment BC. So that's the idea of perpendicular or perpendicularity. Never assume it on a diagram. Okay? You can't assume it. You have to be given that mark. That's not assuming. Okay? So if you have that mark, or if you have one of these statements, it's not assuming. All right, let's do a proof with perpendicularity. So if we are given that in this diagram here, or in this case, we're not going to necessarily do a proof, we're going to do some algebra proof, that ray SR is perpendicular to ray SV, that allows me to conclude that it's a 90-degree angle. So I'm just going to kind of outline some stuff up here, or I can conclude this. And then I'm given that angle TSV is 5 times as large as angle RST. Okay? So I don't know what either angle is, but if I call this angle X, then angle TSV is 5X, 5 times as large as X. So this is 5X and this is X. Now it's my addition property. I know that the two angles add to 90 degrees. X plus 5X is equal to 90. 6x is then equal to 90, and we solve for x getting 15. But the question was not what is x, the question is find the measure of angle TSV, so I substitute that back in to get the measure of angle TSV to be equal to 5 times 15, or 75 degrees. Okay. The last example we want to talk about with perpendicularity is what does this look like in a proof. So remember, in proofs we have to state our givens. So I'm going to state, so I'm going to state my two perpendicular statements, but remember when I talked above, this is a real important idea. Okay. Perpendicular does not tell me that we have congruent angles. Perpendicular tells me that we have right angles, so I cannot go straight to congruent. Okay. The fact that segment AB is perpendicular to segment BC tells me that that is a right angle. Okay? So I can state that this tells me that angle B is a right angle. And again, this is my outline. This is called a flow proof, and we'll talk a little bit about that later on. But I like to outline my proofs in flow proof format. The fact that segment DC is perpendicular to segment BC tells me this angle. So DC and BC is a right angle. So that tells me angle C is a right angle. So if I just kind of talk about my thought process, now I have two angles are right angles. Now I know that my angles are congruent. Angle B is going to be congruent to angle C. That would be the flow proof. This, then I can kind of outline it up here. I can copy that stuff down in those orders into my two-column proof. So a couple things in mind. It has to be written in order. So in my flow proof, in my outline, it goes left to right. Anything that's listed on the right, you have to have everything in front of it listed first. Vertical, you can list in any direction. Okay, so those are all my statements. Now I need my reasons, and we have our if-then statements as our reasons. So we would say if two segments are perpendicular, then they form right angles. And that's totally abbreviating, but I'm going to even let you abbreviate more. Okay, so normally at this point, the next example, you can say same as number 3. Okay, but at this point, I'm going to show you one more abbreviation, and it's going to be even better. Perpendicular, which is what my given was, implies right angle. Done. Okay, so that's as short as you need to make the reason when you have that statement. You just have to make sure, okay, perpendicular implies right angle. Okay, the top implied the next thing. Okay. And then my last reason is that two right angles imply congruence. All right, now let's go ahead and talk about section 2.2. Our goal in this section is recognizing complementary and supplementary angles and then applying some theorems of that. All right, so to start, complementary angles. These are two angles whose sum is 90 degrees. That means they add up to 90 degrees. So we call them the complement of each other. So in this example here, angle A and angle C are complementary, or angle A is the complement of angle C. Okay. And then we can apply that concept here. So here we can't assume anything from this diagram. So technically, the way the diagram's written right now, we can assume nothing. Okay. However, if I had put this diagram in correctly and given you this, now we can assume that angle AFD and angle DFE are complementary angles, or that angle DFE is the complement of angle AFD. And we could use subtraction to find the measure of angle DFE. And then a quick review, if we have a 90-degree angle because they are complementary, because I've now told you that with that mark, then that's the same as 89 degrees and 60 minutes. We subtract 62 degrees and 40 minutes, so the measure of angle DFE is 27 degrees and 20 minutes. All right, moving on. Supplementary angles. Two angles whose sum is 180 degrees, and the two angles are the supplement of each other. So in this diagram, we can assume straight angles. So this should be true, but we can also prove that it's true by adding our two angle measures and showing that it's 179 degrees and 60 minutes, which is 180 degrees. So our angles are supplementary, or one angle is the supplement of the other. And the last, but certainly not least, as we start talking about supplementary and complementary angles, let's talk one proof. And we're going to have a handful of examples we're going to go over together in class, and you'll do some on your own in class. So this diagram, as shown, is what we were given. Okay. Now we can state diagram, since it was here, diagram as shown. Given. Okay. And we can assume one thing from our diagram. We can assume a straight angle. We cannot go and assume straight to supplementary, but since we can assume that it is a straight angle, we want to state that angle ABC is a straight angle, and that's assumed from the diagram. Now, in the future, if you don't tell me diagram as shown given, I'm not going to be super picky on that, but the angle ABC is a straight angle assumed from diagram. We do want that to be stated specifically in your proof. Okay. Now that we know that we have a straight angle, we can say that angle 1 is supplementary, and you can abbreviate supplementary as just sup with 2 P's, to angle 2, and it's because, and watch for our quick shortcut, straight angle implies sup. Okay. So again, if I don't state that I have a straight angle here, I can't use straight angle as a reason. Okay. Then that implied supplementary, so that gave me my supplementary here. So key steps here. One thing I'm going to mention now, and I'll mention it in class again if I remember, is that when we have 2-column proofs, we will typically, on tests and quizzes, give you the format here in this table, but we're going to give you usually more spaces than you need to complete the proof. So here, I did this proof in 3 steps, but there were 4 spaces. I technically could have probably done the proof in 2 steps. There were 4 spaces. Okay, there's going to be some in class that we have maybe 9 or 10 spaces for you as the proof, but you might only need 4, 5, 6, 7 of them. You might not need them all. And it's going to go even further. We'll give you 25 spaces, and you might only need 12, something like that. You might take 30 and make up some of your own, and all of that's okay. Okay, we're getting used to proof. We're going to continue working with it, and make sure you're asking lots of great questions on formatting and things like that. All right. Thanks, folks, and we will see you in class.